Hello, thanks for stopping by. A couple of things I'm going to go over today is tube testers and making sure you're using the correct tubes when you're replacing tubes in old equipment. If you're like me, probably one of the first times you took and ran into a tube tester was when you were growing up. Your radio wouldn't work and your dad would take the back off, take all the tubes off of it, and the next time you went grocery shopping, either at the grocery store, if somewhere around the service counter, or at the drugstore. I've seen them, in both places or whatever. They'd have a tube tester. It might look like this one here. It might be one of these, or it might even be a name brand like this RCA one here. And regardless of what type it was, you take and you read the instructions, and they have a roll chart on it or a booklet with the tell you what socket to take and put your tube in, where to take and set the dials, and then you press the button and it would tell you whether your tube was good or bad. Now once you found the bad tube, somebody would take and come the bottom part where you see all the tubes there, that would be locked up. They'd take and unlock it, take and find a new tube, and sell it to you, and you'd be on your way. Now, some of the better places would take and double check your settings, make sure you had it right. Might even wiggle the tube a little bit, make sure the contacts weren't dirty. And then when they got the new tube out, they'd take and plug that into the tester to show you that the new tube was good. That way you couldn't come back later and say, hey, this tube was bad. As we start working on things ourselves, of course, we want a way of testing tubes. And there's one thing to remember. Unless what you're using is something like this, which only tests for filament continuity, then all tube testers are emission testers. That's just the way they work. They may check it in different ways, but all tube testers are emission testers. Now, one of the first tube testers I bought, all I could afford, was one of these. It's an EMC 211. It's a nice, simple tester. It came with a manual. You took and looked in it, and it would tell you, which where to take and set it. The one setting was for filament voltage. One was for what pin was your filament pin. You'd have a selectivity control, the pot there in the upper right. And then you had a quality test and a short test in the slide switches on the left. And electrically, this is all they were. They had a transformer. When you push the switch up, that tube element was connected to the positive, to high voltage. The other pins would all be grounded except for the filament pin you selected with the filament selector. And when you pushed the quality test, it saw how much DC was rectified by the tube, because there again, all tubes are diodes. They may have more than just a plate and cathode inside, but as far as their action, they're all diodes. They're all rectifiers. So by putting the like in the case of let's say a 6L6, putting the screen in the plate at positive potential and grounding the cathode, when you take and hit the quality test, it would tell you how much current was flowing through the tube. Now, whoever took and manufactured the tube tester, they would have taken ahead of time and either gotten a tube that they tested on a lot better tube tester than these, or got a 5 or 6, say, of any number tube and tested it to take and come up with what a good tube is, and they'd probably say that, okay, a good tube would test 100. That's why most of the testers take and go over 100, because if you allow for leeway. Now, next step above this is a tube tester like the Knight. One thing that's better about this over the EMC, this gives you a lot more voltage selections. One of the downfalls with the EMC is that you only had like 5 or 6 voltages. So like 35 and 50 were the same voltage, 5 and 6 were the same voltage. This lets you take and test it a little more precisely. You can take and put the exact filament voltage that you had in there. What the switches are doing is putting different amounts of plate voltage depending on what the tube is and how it would normally run. And the rest is basically the same. If the switch is down, it's grounded. If it's up, it's to the positive. And then when you take and you press the test button or whatever, it takes and sees how much DC current that you're passing through. And that's why if you take a look, at the schematic diagram for it here, it's really almost as simple as what the EMC 211 was. There's not that much more to it. Just you said you have more filament voltage selections and a few more test voltage selections where you're limited to one test voltage selection with the EMC. This you may have 3 or 4. And now the Knight is the same. You hear people say, well, they have a TV11, that's better than the Knight. The Superior TV11, the only advantage that it has over the Knight is it has one extra control setting, the one that's labeled N there on the sides or whatever, and all that does is totally disconnect whatever internal element is on that pin. And that comes in handy if you have a pin, like there's some tubes that say pin 2 and 5 may both be connected to the same internal element. Well, it's let you just have the one side just being tested and the other side hanging in the air, so you're not grounding both sides of it, maybe getting an extra reading that you don't want to take and get. But otherwise, it's the same thing. You get your filament voltages, your load setting, and it just the same thing as the Knight. And the next step above that, in types of testers, is either transconductance, mutual conductance, some kind of conductance tester. This is one of the simpler models. This happens to be the one I use. This is the Superior TV12. And the advantage of this over the others is this: you take and for the grid, you're putting an AC voltage on the grid, so you're seeing what it actually conducts with a signal on the tube. The others, there was no signal. There was just positive on the one side and negative on the other, and what's the current that flows through when you take and do that. This actually takes and puts a low voltage AC current on the grid to take and simulate a tube in actual operation. Now, this doesn't take and read directly in micromodes like the more expensive ones do, but they do take and give you in the manual, they tell you how to take and set it up and then use formulas to take and come out with micromode readings if you want to take and match tubes or come closer to what the manual says that they are. And now, of course, everybody says, that, if you want to take and do it right, you have to have a Hickok. Here's a Hickok 534. It's got a lot more knobs and stuff like that. The advantage that these have to you is that this lets you set one plate voltage. It lets you take, instead of different screen voltage, lets you take and narrow down what the swing of the grid voltage is, so you can take and set the tube a lot closer to what a tube manual says that the tube should have. And then when you get everything set and you press the test button, you're testing the emissions. At those particular settings, what are the emissions? And of course, because you have all those different settings or whatever, it's a lot more complex inside, because there are several different power supplies for the plate, the screen, the grid, and stuff like that. And that's what makes them so expensive, because there's so much into it. But for what the majority of us do, all we want to know is that, is there a short in the tube? Relatively, how good is the tube? Okay, if 100 is perfect or whatever, are we in the green area on our tester and stuff like that? And that's really all that we care about. If you want to take and match tubes, then yes, this is something that you'd want to do. But then again, if you're getting into things like that, you can take and do something like this and make your own tube tester. This was taken and made by a guy that all he does is work on audio amplifiers. So in the audio amplifiers, it's mostly like 6L6s, 6F6s, tubes like that, plus the preamp tubes, 12AU7, 12AX7 or whatever. This lets him take and choose a couple different plate voltages, a couple different screen voltages, and set the bias or whatever. So, okay, there's no tube tester that takes and goes with it, or tube chart that goes with this or whatever, because basically all this is made for is matching tubes. If you take and you put two tubes, or the two sides of the 12A AX7 or whatever, if they're both equal, then those are matched. If you take and test two 6L6s without changing any of the other dials or whatever, and you get the same readings on the meters as far as voltage and current, then you know that they're matched. But that's all it is. Now, one other thing, as far as testing tubes, some of the tube testers, you'll see they'll have a life button on them. And supposedly you take and press that, and it'll take and give you a little clue on, how good the tube is. Now, you can take and do the same thing. If you take and you look here, in this here, I took and put a 6L6 tube, or 6K6, I'm sorry, my mistake, tube, and let it warm up, and then press the test button, and you can see it's reading green and reading it right about 90, and that's with the 6.3 volt filament. Then I turned the filament voltage down to 5 volts, and you see how fast it started dipping down, and I'll take and switch it back up to the 6.3 volts, and you see it'll climb right back up to 90. Now, is it a good tube? All depends on what you're using it in. If you have a fairly constant house voltage and things like that, then I'd say yes, that's probably a good tube. Now, this one here, this is a new old stock 6K6 tube. And starting out at the 6.3 volts, okay. Hit the test button, it's right up there at 120 and stuff like that. Now I took and switched it down to 5 volts. You notice the needle just barely dropped. It dropped, what, 2 points? And now I'll take and switch it back up to 6.3. and you'll see it take you slowly climb back up to the 120 again. Where are you going to notice a difference there? You're going to notice a difference there like if you have equipment switching on and off in your shop. Now, one other thing I want to take and go over. You take and you look, when you're restoring radios or whatever, most of the radios that we're restoring have been worked on by others. So we have no guarantee that the tubes are actually, correct replacements. Now, if you take and look, this is a schematic for the airline radio that I'm working on. And you notice that the converter here is the 6SA7. The RF amp and the IF amp are 6SK7s. And the audio detector is a 6SQ7. There's no letters after the 7s. Now the 6J5 and the 6K6, they're both GTs. GT stands, that's glass tube. The others aren't. Now, my particular radio, one of the 6K7s, looked like the black metal tube at the left here. The other 6K7 that was in there was replacement. It was the glass tube. It was the 6 SK7 GT on the right hand side there. Now if we take and look, if you remember, anybody who's worked on real old radios, or if you've seen real old radios being worked on, you've seen tubes that look like this. They had some kind of a shield on them. If they didn't have a close-fitting shield like that, they had either slip on, slip over, just several different kinds, but some kind of metal shield down over the tube. And what that did, that kept the elements inside the tube from being affected by radiation from the IF can, from another tube, from the transformer, from almost anything. Well, when they wanted to switch from the old style bases to the octals and stuff, that a lot of the first tubes were the metal tubes. And if you look on the in the tube manual for the tube, you'll see that pin 1 of 6SK7, which would be the metal tube, no letters after it, is connected to the shell, which means that if you take and ground that, then it acts just like having a tube shield down over the tube. Now, if you look at the 6SK7G or GT there, all that's grounded from pin 1 is that base sleeve. Just the metal right above the base or whatever, but there's no grounding on the glass. So if you have any noise in the radio or what, then you could very easily take and get, noise in your signal, a little hum in the background or something like that. That could drive you crazy checking, especially if you took and changed all the tubes and put in exactly what was in there, figuring if those were correct. So it's kind of like, pay attention. If it calls for just plain number tubes, those are almost assuredly just the metal tubes with the built-in shielding or whatever, and that's what you want to take and replace them with. If it has GT or something on it, yeah, you can always take and use, in most instances, you can always take and use a plain tube in place of a G or GT, but you can't use a G or GT in place of a plain tube. And I think that's just about it for this one. I probably talked way too long. I'm starting to be as bad as Doug. Uh, I want to thank everybody for stopping in. Hope everybody's still holding up good, and have a good day.